example 4. And I have to say, you know, this might be a shape you've never seen before, right? What kind of a function would make a shape that looks like this? It has like 3 pieces to it, right? This little line, and this little downhill line, and then this uphill line. Yeah, it does have a lot of pieces to it. In fact, it would be known as what's called a piecewise function. It's actually lesson 1-3 for next week. I don't really care about what function produces this picture. All I care about is, what if I took this generic f of x and I produced this instead? What would a negative out in front and an x plus 2 on the inside do to this graph? Say that another way. F of x might be x squared. It might be the absolute value. I've said this before. It might be all kinds of different functions, right? This is just some generic function that whatever the f of x was, it produced this picture. It produced this picture. Right? You go through here and you say to yourself, well, is there anything inside this blue circle that would cause the graph to reflect? And I would say yes, this negative sign would do that. All right? Is there anything in here that might cause this graph to dilate? For this, we're looking for a multiplier. You'd be looking for like a 3 out here, or a 0.2 or 0.5 in there. I don't see anything being multiplied. So I think in this problem, we do not need to worry about dilating the graph. That's good. However, since there's an x plus 2 inside parentheses, I think we will have to translate this function. And when the x plus 2 is in the parentheses, I believe it goes left 2. And since this negative is outside the f of x, I believe it flips over the x-axis. Remember, negative on the outside, like this, flips it upside down, right? The b becomes the upside down b. That's going to happen here. This shape is going to flip. Here we go. The reason I wanted you to write r, d, t in that order is that's the order in which I want you to perform these transformations. So step 1, all those points that you jotted down right here, A, B, C, and D. From left to right, let's just call them A, B, C, and D. Step 1 is to reflect them all to their opposites for their y coordinates. Negative on the outside makes negative 4, 2, which is point A, become negative 4, negative 2. We are flipping this upside down using the x-axis as our reflection line. Point B, which was left 2, up 4, should go left 2, down 4. Point C, left 1, up 3, go left 1, down 3. And then point D was right 1, up 7, go right 1, down 7. Once you connect your dots, you should see the mirror image of the blue line below, underneath the x-axis. That took care of reflecting the graph, so we're done taking care of that minus sign, that negative sign. To finish the problem, you would take each of these points and you would shift them all left 2 because the x plus 2 is in the parentheses. Look at the next problem. The f of x plus 3, that's outside the parentheses. That's different. This would be different. Okay? There we go. We're just going to take each of these red dots now and bump them left 2. Left 2. Left 2. Left 2. Trace it. If you're not using fancy colors like I am, you would just give a little arrow and indicate that this is folder. You could highlight it if you have highlighters. Anything that you want to do to indicate which of these shapes is your final answer. I'm going to keep rolling right into example B. Again, this will be recorded. It is being recorded, so you can watch both of these back later if you need to. All right? Just for time, so we have a little bit of time at the end to take questions, we're going to roll right into example B. So again, whatever f of x was, it produced this blue graph. Now, we're going to see what happens. Are there any reflections, dilations, or translations? For reflections, I don't think we have any. Because when I look here, I don't see any negative signs. Nothing is taking this graph and flipping it left, right, left or right, or up and down. So we're going to put an X through reflections. No. Dilations, we just learned about this today. But before dilations, it could have been a vertical stretch, a vertical compression, horizontal stretch, or horizontal compression. When I see a fraction out in front of the f of x, I think it's going to be a vertical compression. So it's going to cut the y values in half. This is where some students tend to maybe get a little, how did you know that? Well, the 1/2, if it's out front, not in here with the x, cuts those y values in half. Just by the positioning of where that dilation constant is. Translation, if this parentheses was out here, I'd say left 3. Since it's not, the plus 3 is on the outside of f of x, I think it translates up 3. So here we go. Just like in the last problem, the x-axis served as our reflection line. This time it's going to serve as our dilation line, our reference line for how we dilate this thing. I've seen students like shrink these down like this, something like that, and that's not correct. You don't shrink it like inside of itself. Right, those are going to disappear. Let's get a little messy. You want to take each of the points, A, B, C, and D, and just cut their y's in half. So they're going to get shorter and closer to the x-axis. So point A was -4, 2. It's going to be -4, 1. And cut the 1 in half. -2, 4, point B is going to become -2, 2. I cut the 4 in half. -1, 3 for point C will become -1, comma 1.5. That's half of 3. And finally, 1, comma 7 will be over 1 up 3.5. So look at that. The shape got less steep, smaller because of that dilation constant. One more thing, you'll see that. Okay? This height was 2, now it's 1. This point was up 4, now it's 2. This was up 3, now it's 1.5. This was up 7, now it's only up 3.5. Everything got reduced by a fraction of 1/2. I'm going to wrap it up, close the video, answer questions right after we move this thing up 3. Translate it up 3. Every red dot has to bounce up 3, up 3. This guy up 3, put it right in between there, and then this one up 3, and there. Blue this time is my final answer. I would be looking for this blue little lightning bolt with the word final, or bold, or highlight, or a special color. All right, I'm seeing some things come into the chat window, so I'm going to address those now. Let me stop the video and save that.